Your VPN connects. It sends 3 messages and they go through. Then the next one sits on the spinner. Media never loads. A voice call connects and drops at 30 seconds. This isn't a buggy app and it isn't your connections. Iran's filtering system is watching the shape of your traffic and quietly degrading it in real time. In this video, I'll show you what actually survives in Iran in 2026 and why it survives. I run managed Telegram hosting on real Singapore hardware, dedicated phones on real carrier SIMs, so I spend a lot of time looking at what blocks Telegram in different countries and what gets around it. Iran is the hardest case I deal with. The block dates back to April 2018 and it never lifted. What changed is how it works. It went from a crude IP block you could route around with any proxy to a layered adaptive system tuned to make circumvention frustrating rather than impossible. This is for anyone in Iran who needs Telegram for family, for work, or across the diaspora. Here's the plan. First, why your VPN keeps dying, the actual mechanisms doing it, then what still works, ranked honestly by survival rate, and then the full managed setup, why a Singapore cloud phone changes the threat model, what it costs, and how to keep the accounts safe from inside Iran. Start with the landscape, because it explains everything else. 3 telcos carry the bulk of Iran's mobile traffic. MCI, then MTN Irancell, then Ratel. All 3 answer to the Communications Regulatory Authority, which takes its directives from the Supreme Council of Cyberspace. On the fixed line side, ISPs routes through the National Information Network, Iran's state-controlled backbone. That backbone gives regulators a single technical choke point. When a blocking directive comes down, every ISP implements the same thing within hours. There is no carrier you can switch to that escapes this. The thing that matters for you is what happened recently. Through late 2024 and across 2025, technical units upgraded the deep packet inspection hardware across the major ISPs. Probe measurements collected inside Iran show a sharp jump in protocol blocking events starting in the 4th quarter of 2024. Telegram's traffic started getting throttled rather than blocked outright. That word, throttled, is the whole story. A hard block is honest. Throttling is calibrated to make circumvention unpredictable, and unpredictable is what breaks most workarounds, because you can't tell whether it's the regime, your device, or your VPN. So why does your VPN keep dying? 2 reasons. The first is deep packet inspection and protocol fingerprinting. Iran's ISPs run ZT and Huawei DPI hardware that looks at far more than destination IPs. It examines packet size distributions, the timing between packets, and the structure of the TLS handshake. OpenVPN produces a recognizable handshake pattern. WireGuard's handshake initiation is a fixed-size packet that's trivially distinctive. Obfuscated protocols like OBRFS4 and ShadowSocks buy you time. But the DPI signature databases get updated, and when they do, the window closes. The goal isn't a clean block, it's deliberate degradations. The second reason is known IP block lists. Voices, DigitalOcean, Vultr, Linode, most identifiable data center ranges are blocked or heavily throttled from Iran. Shared residential proxy pools are a partial answer, but they run on a predictable burn cycle. A provider sells access to thousands of residential IPs. One customer triggers abuse detection through scraping or high-volume traffic, and the whole subnet gets flagged. You buy a fresh endpoint on Monday, it works for a week, then it dies. That's just how shared pool economics work. The only real escape is an IP that belongs to you alone and isn't shared with anyone else. And then there's the Telegram problem itself. Telegram's mtproto protocol is built into the app and handles its own encryption. The in-app proxy setting routes traffic through relay nodes without a separate VPN. But in Iran, in 2026, mtproto traffic has a recognizable fingerprint even when the destination is just a relay. So the DPI systems rate limit it instead of blocking it outright. Text arrives after a 5-second delay. Media never loads. Voice connects and drops at 30 seconds. That's the degradation you feel, and it's deliberate, because it makes you blame your device instead of the ISP. So what still works? Let me rank it by survival rate, worst to best, and be honest about each one. Third place is mtproto proxies and the app native relay. Telegram includes a proxy setting under Settings, Data and Storage, Proxy. The community maintains lists of working endpoints, and during calm periods with no active crackdown, this gets you functional text messaging. But the ceiling is low. During protests, election weeks, anytime regulators tighten the screws, these fail first, because their traffic signature is the easiest to target. For a family group chat on a normal Tuesday, a fresh proxy might be enough. Don't depend on it for anything you can't lose. Second place is SOCKS 5, rated through a clean mobile IP. A SOCKS 5 endpoint backed by a genuine mobile carrier IP in a friendly jurisdiction is far more durable than any data center VPN. Mobile carrier ranges carry a different traffic profile from data center ranges, and they haven't historically been targeted in Iran's block list the same way. The weakness is the same burn cycle. A shared mobile pool reproduces the exact problem I described earlier. The fix is a dedicated IP that belongs only to you, so it doesn't get flagged because some other customer tricked abuse detections. The first place, and is not close, is the full managed cloud phone. This is the architecture that changes the threat model entirely. Instead of your device in Iran running Telegram and pushing that traffic through a proxy, a physical Android phone in Singapore runs your Telegram session around the clock. Your local device connects to that phone through a browser-based remote interface. What your Iranian ISP sees is encrypted HTTPS traffic to a browser UI endpoint. Telegram's mtproto never touches your local network at all. The DPI has nothing to fingerprint because the protocol isn't on your link. Now, why Singapore specifically? Because that isn't a random choice. Iran's blocking decisions follow a cost and benefit logic, not a block everything logic. Freedom House's reporting documents that the authorities block services when the political benefit is high and the diplomatic cost is low. Blocking a Singtel or Vibervi mobile range wholesale creates friction for Singapore companies running legitimate trade with Iranian counterparts. Shipping firms, commodity brokers, financial intermediaries operating in the space between sanctions and Singapore's own enforcement posture. That friction is a cost the Supreme Council of Cyberspace prefers not to incur. Singapore carrier ranges: Singtel S9506, StarHub S4657, M1 S18081, Vivify S137371 have not appeared on Iran's block lists for Telegram. That's structural, not accidental. The latency trade-off is real and worth knowing before you commit. Tehran to Singapore is 120 to 180 milliseconds round trip on every Telegram action. For reading and sending text, you won't notice it. Telegram is asynchronous by design, and that delay is below the threshold of perception. Voice calls have a mild but noticeable lag, like a congested mobile call. For video, the added latency stacks on top of any jitter on your local connection, and you will feel it. That's the honest trade. You're accepting latency in exchange for reliability, and for group chats, channels, bots, file sharing, and business messaging, that trade is clearly worth it. Here's how the setup actually works. We run a concierge onboarding during the current pilot. You join the waitlist and the team provisions a dedicated Android device in the Singapore farm with a real Singapore SIM, Singtel, M1, StarHub, or Vivify depending on inventory, tech-powered and connected continuously. Then the team sends you a one-time browser session URL into the CSF interface. You open it in any browser and see the phone screen rendered live. You open Telegram on that phone, enter your own number, and receive the OTP on your real SIM, exactly like any normal login. You type it yourself. The team never sees the code and has no access to your account. From that point, the session is yours, running 24 hours a day from a Singapore mobile IP. Now, account safety from inside Iran, because the architecture is only half of it. Your number's country code is a real trade-off. An Iranian plus 98 number has continuity. Your contacts already have it. No explanations needed. The risk is that Iranian telcos can be compelled to hand over SIM access or call records, and if your account draws attention, that number connects it directly to an identifiable local SIM. A non-Iranian number, Hue, Turkey, Georgia, adds a layer of separations. Georgian virtual numbers are popular in the Iranian Telegram community because they are cheap to maintain and hard to legally compel. The cost is managing that number from abroad and telling your contacts. Enable two-step verification before anything else. Settings, privacy, and security. Two-step verification. Set a password that is not stored on your Iranian device and not tied to an Iranian email. If your SIM is intercepted and someone receives your OTP, that password blocks the login. This is the single highest leverage account protection there is. It costs nothing and takes 2 minutes. Do it now, not later. Turn off contact sync. Telegram uploads your address book to map your social graph on its servers. Go to Settings, Privacy and Security, disable Suggest Frequent Contacts, and revoke the contact's permission at the Android level. And IP metadata matters more than most people realize. When your session runs from a Singapore mobile IP, the IP logged in Telegram's infrastructure is that Singapore carrier IP, not an Iranian one. That doesn't make you anonymous. It removes one data point from the profile an adversary could compel Telegram to disclose, and for sensitive accounts that reduction is meaningful. The practical advantage you only appreciate after leaving it is persistence. The phone in Singapore doesn't sleep, doesn't restart, and doesn't depend on your local internet being up. Messages arrive at the cloud phone whether or not your device in Tehran is online, and your local connection will drop multiple times a day during peak hours and during sensitive periods. When it does, you just reconnect to the staff interface and everything is waiting. That persistence is the thing proxy setups simply can't replicate. I'll be honest about the cost too. The staff browser interface is functional, but it isn't a native app. You reach your sessions through a browser tab, and getting notifications onto your local device takes a configuration step the onboarding team walks you through. Most users adapt within a day or two and decide the reliability is worth it. If the phone hits a problem, the team monitors the farm, restores the session, and notifies you. So here's the soft pitch, and I'll keep it honest. If you spent the last year cycling through VPNs in Iran and you're tired of managing it, this is what managed Telegram hosting on Telegram Vault. Org is built for. A real Singapore mobile IP on Singtel, M1, StarHub, or BBFi on real Android hardware in our farm. Your own number stays yours, you log in once and type your own OTP, and we never touch the code. The session runs 24 hours a day outside the jurisdiction entirely. Through IP ranges Iran's regulators have structural reasons not to block. Plans start at $99 a month for one account and run to $899 for 15. Payment takes crypto or card, and crypto works when Iranian banking cards can't. It's concierge onboarding during the pilot, and Iranian users get priority. Join the waitlist at telegramvault.org and use code TGYT for 30% off your first month. The link is in the description. If this helped, subscribe, because I'm working through how Telegram survives in the hardest countries one at a time. The next one covers Russia, where a 2025 law went after proxy use itself, which changes the legal threat even though the technical answer stays the same. Thanks for watching, and I'll see you in the next one.